Good morning, everyone. My name is Yashwant Bhattapati, and today I will present my research on diode behavior under extreme temperatures. This topic is highly relevant in industries like space exploration, automotive, and industrial automation, where electronic components must function reliably under extreme thermal conditions. Understanding how these diodes respond to the temperature changes is crucial for designing stable and sufficient electronic circuits used in harsh environment. Next, moving to the next slide.
Diodes are one of the most essential electronic components, allowing current to flow in one direction by blocking it in another. In real-world applications, diodes are widely used in power regulation, voltage protection, and rectification. However, in harsh environments like space, temperature can drop minus 100 degrees Celsius or rise above plus 150 degrees Celsius. At such extremes, diode performance can degrade, affecting the stability of critical systems like satellites, aircraft, and medical devices. This study aims to analyze the stimulate diode behavior. Under these conditions, to understand the impact and purpose potential solutions. Next, moving to the next slide. This slide is about the objective of the study. The key objective of this research is to study and stimulate how a diode behaves under extreme temperatures. Specifically, we focus on point number one, understanding electrical changes, including forward voltage drop and leakage current variation, identifying temperature compensation techniques to improve diode performance, helping engineers choose the right diode temperatures for space, automotive, and industrial electronics. By conducting simulations across a temperature range of minus 100 degrees Celsius to plus 150 degrees Celsius, we aim to provide valuable insights for designing more reliable electronic circuits. Next, moving to the next slide. Based on this slide is based on the theory we accept to observe the following trends already we know. The forward voltage drop decreases as temperature increases because carrier level. Leakage current increases exponentially at high temperatures, leading to power loss and efficiencies. These effects highlight the need for advanced materials and cooling mechanisms is in high temperature environments. Next, moving to the next slide. This slide is of circuit design. To stimulate the diode behavior, I designed a circuit with a diode, resistor, a voltage source, temperature control module. A diode chosen for its temperature dependent properties is 1 and 4 and 48. By implementing this setup, we can closely observe how diode characteristics change with temperature variations as shown in the graph. Stimulate setup and execution. For business analysis, I used LT-Space and Proteus, two industrial standard circuit stimulation tools. The key parameters for our stimulation were voltage range is 0 to 5 volts to steady diode characteristics under normal operation, means under normal temperature and pressure. Is like room temperature, we already know it is 27 degrees Celsius. The temperature range is like minus 100 degrees to plus 150 degrees Celsius to replicate space-like conditions. Time setup adjustment is about ensuring accurate, consistent, and steady-state analysis. It is more precise. These stimulations help us visualize and qualify how extreme temperatures affect diode performance in real-world applications. Let's move to the next slide. It is it is the theoretical background for this study and project. To understand why diode behavior changes in temperature, we refer to the Shockley diode equation. That is, as shown in the display, as shown in the slide, we already know the Shockley diode equation. In our classes, we already studied this. I is equals to IS bracket E power VD by VT minus 1. And where IS is the reverse saturation current, VD is the diode voltage, and VT is the thermal voltage. Key theoretical insights are: first point, as temperature increases, carrier mobility increases, reducing forward voltage drop. Reverse saturation current IS increases exponentially, causing significant leakage currents at high temperatures. These effects can lead to circuit instability, power losses, and reduced efficiency, making it essential to design temperature compensated circuits. Next, moving to the next slide, it is the analysis of results of this study. Now, let us look at the actual stimulation results. In the graph 1, as shown in the graph 1, the forward voltage drop versus temperature. As expected, the forward voltage decreases with increasing temperature. This is because higher temperature increases the number of charge carriers, reducing the voltage needed for the condition. For graph 2, leakage current versus temperature, leakage current increases exponentially at high temperatures. This happens because of increased thermal excitation, which generates more unwanted charge carriers. Next, the key point is that the results align with theoretical predictions, providing that diode form degrades slightly at extreme temperatures, which must be considered in circuit design. Then finally, the last slide, the real-world applications. Understanding diode behavior under extreme temperatures is crucial for many industries. One, the satellite power systems, diode regulate voltage is harsh space environments. Two, in aerospace electronics, components must withstand extreme variations in aircraft and spacecraft. And third, automotive electronics. In this, like the sensors and safety circuits must remain stable in both hot and freezing conditions. The third one is like medical equipment, MRI scanners, and implementable devices, as we all know, required and precise electronic performance. Reliable energy systems, solar panels, and wind turbines operate under fluctuating temperatures. Industrial automation, electronics in factories, and outdoor installation must be removed against temperature variations. The key message: a deep understanding of diode temperature behavior helps engineers design more efficient and durable electronic systems across various industries. The, the conclusion is to summarize the study demonstration that diode exhibit decrease in forward voltage and increase in current at high temperatures. Number two, the proper material selections and circuit designs are crucial for stable performance in extreme environments. For future research, should focus on advanced semiconductor materials and vacuum chamber testing to enhance diode reliability in real-world applications. This research is a step toward developing electronics that can operate efficiently in space, automobile, and industrial environments. That concludes my presentation. Thank you for your time and attention. I would be happy to answer any questions you may have.